Okay, so the same way I can even write it for a common, I can also find what is alpha cutoff frequency. Since beta is for common emitter amplifier, alpha is going to be for common base amplifier. So when you find a common base amplifier, just like how I derive the expression for AI, I can derive the expression for AI for a common base amplifier also. By the same assumptions, I will get AI equal to minus HFB by 1 plus J into F by F alpha. So here you see minus HFE by 1 plus J into F by F beta in common emitter configuration. In common base, minus HFB by 1 plus J into F by F alpha. And what is F alpha? F alpha is 1 by 2 pi RB dash E into 1 plus HFV into CB dash E. So 1 by 1 plus HFB is approximately equal to HFE. So I can write F alpha is approximately equal to HFE by 2 pi into RB dash E into CB dash E. So this common base amplifier has a higher 3 dB cutoff than a common emitter amplifier. That is evident here because you can write F alpha in terms of F beta. So F alpha equal to some constant term into F beta I can write. So which means that F alpha is so much times higher than F beta. So when you compare common base and common emitter amplifier, common base amplifier has a higher 3 dB cutoff frequency than a common emitter amplifier. So 3 dB cutoff frequency is very high means I'm going to have a larger bandwidth also. So gain of common emitter configuration may be very high, but the bandwidth is very large only in the common base amplifier because we find here F alpha equal to some constant K into F beta. So which means that F alpha is very high compared to F beta. So the cutoff frequency for common base configuration is very larger compared to the same cutoff conditions for common emitter. So by concluding that the cutoff frequency is very large, we understand that the bandwidth of CB is larger compared to CE. So gain is large for CE, but bandwidth is large only for common base. It is evident from the calculation of F alpha and F beta. So we are not blindly making conclusions here. We are concluding based on the expressions of F alpha and F beta. So when you draw the frequency response graphs, you see here, first you will have this alpha cutoff frequency will come somewhere here, but the beta cutoff frequency is coming very much early. You see the difference? So beta cutoff frequency is coming around 10 power 5 hertz, or I can say 10 power 5 hertz is equivalent to 10 kilohertz. But you see alpha cutoff frequency is coming somewhere close to 10 power 7 hertz. So 10 power 7 hertz is to 10 megahertz. This is very larger. So if your application is demanding a very high bandwidth, but my gain can be okay, then you go for common base. But if the application is demanding a very larger gain, but bandwidth should be very small, then you can go for common emitter. Okay, so F alpha is the alpha cutoff frequency at which the common base current value will drop from 3 dB. Whereas in F beta, we say that the common emitter current gain is going to drop by 3 dB. So in the same graph, if you plot F alpha and F beta, you will find that as per theory, we find that F alpha is very much larger than F beta, which is also evident in the actual graph. You can see F alpha is very much greater than F beta. So the bandwidth of common base amplifier is very large when compared to the bandwidth of common emitter amplifier. These are some of the important conclusions we make with respect to the cutoff frequencies in high frequency